Assalamu alaikum everyone. My name is Arish Asif Khan, and today we're going to start a new chapter in chemistry, which is Electrochemistry Unit 6th from class 9th chemistry book, Federal Board National Book Foundation. So oxidation and reduction, these two reactions are known as redox reactions. Electrochemistry is a branch of chemistry that deals with the interconversion of chemical and electrical energy. Oxidation and reduction are the fundamental chemical processes that always occur together in reactions which are known as redox reactions. Now, the definitions of oxidation and reduction. There are four key points. In terms of oxygen, oxidation is the gain of oxygen by a substance, and reduction is the opposite of that, which means if oxidation is the gain of oxygen, reduction is the loss of oxygen. Let's have an example. The extraction of an iron. This example is given in your class 9th chemistry book. In a blast furnace, iron oxide, which is Fe2O3, it is reduced to iron Fe by carbon monoxide. Fe2O3 is also known as ferric oxide, but the normal iron, which is Fe, is known as ferrous oxide. So as you can see, Fe2O3 has been reduced to Fe only, so it lost oxygen. It lost 3 atoms of oxygen, which means that it undergoed reduction, which is the loss of oxygen. Now there is another key point. It is in terms of hydrogen. If oxidation is the loss of hydrogen by a substance, then reduction will be the gain of hydrogen by a substance. An example is of the combustion of acetylene. Basically, in welding, there are two types of welding: electrical welding and gaseous welding. So when you have acetylene and you mix oxygen with it, it gains oxygen. And as you can see, it loses hydrogen. So this means that the combustion of acetylene undergoes oxidation. Let me repeat it again. When you have acetylene, which is C2H2, it will burn in oxygen, which means it will turn into oxyacetylene. So this means that C2H2 will lose its 2 hydrogen atoms, and the final chemical formula will be C2. So this means it's undergoing oxidation. Now O2 has gained hydrogen. The 2 atoms of hydrogen were lost from acetylene and they went to the oxygen. So this means that the reduction was formed on oxygen, and on the acetylene gas, oxidation had been occurred. Now we have another key point. It is in terms of electrons. Oxidation is basically the loss of electrons, and the reduction is the opposite of it, which is the gain of electrons. Now in terms of oxidation state, which is also known as oxidation number, in oxidation, an increase in the oxidation state or oxidation number of is oxidation, but reduction is when there is a decrease in the oxidation state. Now we have an example. For example, cupric oxide, which is CuO, it reacts with zinc. So if you can see, copper, which is Cu, it is an oxidation state of +2. We basically got its electronic configuration. So this means that copper forms a cation of +2. After the reaction, it becomes pure copper, Cu, with an oxidation state of 0. This decrease of +2 to 0 signifies reduction because the copper gained electrons instead of losing them. Now another example is of zinc. Zinc starts with an oxidation state of 0, but it gained +2 electrons from copper. So this means when it gains electrons, that oxidation is being occurred. Zinc was losing electrons, and the increase from 0 to +2 signifies oxidation. Now basically we learned in the previous chapters that +2 stands for losing 2 electrons and -2 stands for gaining 2 electrons. So in this situation, when it says that zinc has lost electron, it basically means that zinc lost 2 electrons regardless of the positive sign. So the key takeaway was that all the four definitions of oxidation and reduction describe the same underlying process of electron transfer. Applications of steel mills and acetylene gas. So let's start. So firstly, steel mills and iron extraction from the blast furnace. In steel industries, iron is extracted from iron ores, mostly iron oxides like Fe2O3, using a blast furnace. This process involves removing the oxygen from the ore to get the pure iron metal. Now let's explain this process a bit. The iron ore is also known as Fe2O3. It contains iron combined with oxygen. As you can see in this molecular formula, Fe, which is basically iron, it has 2 number of atoms, and oxygen, it has 3 number of atoms. So this is the iron ore. Now coke is a form of carbon, or you can say coals. It is added into the blast furnace, and the coke reacts with oxygen to form carbon monoxide. Then the carbon monoxide pulls the oxygen from the iron ore, which forms the carbon dioxide. This means that oxygen has gained 2 atoms. The iron is left behind in its pure metallic form. Now, as you can see, oxidation and reduction in this reaction. For example, we had Fe2O3 plus carbon monoxide. So basically carbon monoxide came to the right hand side. When it was heated, it gained oxygen. When an element gains oxygen, what does that mean? That means that carbon monoxide gained oxidation and it underwent oxidation, because the number of electrons or the atoms in the oxygen has increased to 2. Now in Fe2O3, on the right hand side, it has been converted to Fe only, which means that we lost 3 oxygen atoms. So this is the reduction. So if you want to balance this equation, what can you do? So on the left hand side, we had 2 atoms for iron. So if you place 2 Fe here, this means that you will have 2 Fe on the right hand side. But if you look closer, if there is 2 Fe here, then this means that 2 2s are 4. So you will have basically 4 iron atoms. But I do not want that. So what can I do? Then we have acetylene combustion in welding. Acetylene gas, which is known as C2H2, this means carbon and hydrogen, it is commonly used in welding processes. When acetylene burns in oxygen, it produces a very hot flame called an oxyacetylene flame. Basically, this means that the acetylene gas had gained oxygen and it is used to melt and cut metals. Now acetylene was mixed with oxygen and then ignited. It then reacts to form carbon dioxide and water. A large amount of heat is released for the welding purposes. So look here in this unbalanced equation, we have carbon 2, hydrogen 2 and oxygen 2, and then it was converted into CO2 plus H2O. Now what does this mean? This means that C2H2, which is acetylene, was converted here and it lost its hydrogen atoms. It lost 2 hydrogen atoms. This means that it underwent oxidation. Now in oxygen we have 2 atoms. If you see, it gained hydrogen. It gained 2 atoms of hydrogen. So this means when you gain hydrogen and lose oxygen, reduction is occurred. I hope you guys liked my video. If you did, make sure to subscribe to my channel and hit the bell icon so you can never miss a future lecture. This is Arish Asif Khan, and today we're gonna cover these concept assessment exercises from the electrochemistry unit 6th chapter from class 9th chemistry book. So let's start. So exercise 7.1 states that you need to identify the elements undergoing oxidation and reduction. We covered in the previous lectures that oxidation has 4 key points and so is reduction. Basically, reduction is the opposite of oxygen. I mean oxidation. So look at this first chemical reaction. We have nitrogen with 2 atoms plus hydrogen with 6 atoms. Why? Because 3 has been multiplied by 2. And then it has been converted to 2 nitrogen and hydrogen 3. So we need to find the element which has undergone oxidation and reduction. So look at nitrogen first. Nitrogen has been converted and it gained 3 atoms of hydrogen. So when you gain hydrogen atom but you lost oxygen atom, this means that it's going reduction. So nitrogen 2 gained hydrogen atoms, 3 to be precise, so it undergoes reduction. Now if you see here, we have 6 hydrogen atoms. Now when we had 6 hydrogen atoms, we had basically 2 hydrogen atoms here, and then we went to the right hand side, which is the product section, and then we had 3. So basically we lost electrons to form bonds with nitrogen. So this means when you lose electrons and your oxidation state increases, you're gonna undergo oxidation. Now another example, as you can see, we have 2H2 plus O2 and the product is 2H2O. Now hydrogen basically combined with oxygen. It gained 2 atoms of oxygen, so hydrogen undergoed oxidation. Then oxygen, it gained hydrogen atoms, so this is reduction. Now this is the same example we went through earlier. Fe2O3, it has lost oxygen, so it undergoed reduction. And we have carbon monoxide, so it gained 2 oxygen atoms to form CO2, which is carbon dioxide, so this underwent oxidation. Now another example is of aluminum and oxygen. As you can see here, we have 4 aluminum atoms. So aluminum has lost those 4 and it lost electrons basically. It had 4, now it gained 2. So this means 4 negative 2 is 2. So oxidation has been occurred. And even here on oxygen gained 1 extra electron. It had 2 before, but it has 3 now. So what does this mean? Reduction was occurred. Now let's go on to the next exercise. As you can see, we have this reaction and we need to still find the oxidation and reduction in terms of electron transfer. So basically we have 2Ca plus O2 and it's converting to 2CaO. So look here. Basically we had 2 calcium atoms here, but on the right hand side we gained 1 oxygen atom. So this means when you gain an oxygen atom, oxidation has occurred. Again we have oxygen, it gained calcium, it gained electrons, so reduction is being occurred. This is another example. As you can see, we have 4Na plus O2, 2Na2O. So what is happening here? We basically have Na, which is sodium. It lost electrons. It had 4, but it has 2 now. So when it loses electrons, this means it underwent oxidation. And oxygen, it gained electron. It gained electrons of sodium. So this means reduction was occurred here. And the rest are the same. I want you guys to try to attempt this yourself. If you have any doubts, you can try to contact me through the comment section, or I have given my emails in the link box, so make sure to check that out. I hope you guys liked my lecture. If you did, make sure to subscribe to my channel and hit the bell icon so you can never miss a future lecture. Thank you. Welcome everyone, my name is Arish Asif Khan and today we're gonna talk about the oxidation state and oxidation number. I thought it would be very important to delve into this topic much deeper because a lot of people do not understand what oxidation number means and how we can find the number of oxidations in an element or a compound. The oxidation state of an uncombined or free element will always be 0, like aluminum, hydrogen, H2 or C60, which is basically an isotope of carbon. For simple ions, the oxidation state of a simple ion will be equal to its charge, like aluminum will be positive 3, hydrogen plus will be positive 1, and 3 minus will be negative 3, and so on. And then for complex ions, the sum of these oxidation state will be equal to their charge, which means if we have OH minus, so what is the sum of oxygen, which is negative 2, it will be added with positive 1, so the answer will be negative 1. This is the charge of this complex ion. Now for compounds, the sum of the oxidation state will always be 0. For example, hydrogen has plus 1, chlorine has minus 1, they both will cancel each other out and the resultant will always be 0. And then the last is the oxidation state of some elements in groups, like the group first, which is positive 1, group second will be positive 2, group third will be positive 3, and group 17th will be -1. Why? Because they only need one electron to complete their outer shell and form an octet.